Hello viewers, in today's class we are going to discuss an important integral involving the fractional part function, right? So here we'll solve this integral where we have to integrate this function, that is the fractional part of x over pi, from 0 to pi, right? So here our integrand is a fractional part function, right? So let us first call this integral as I, right? So here we'll make use of the concept of fractional part function to evaluate this integral, right? Now let us first see the definition of fractional part function, right? Now see, the fractional part of y is defined as y minus greatest integer of y, right? So this is the definition of a fractional part of y, which is the difference of y and greatest integer of y, right? And see, the domain of the fractional part function is the set of all real numbers, right? And the range of this fractional part function is from 0 to 1, right? So this is closed from this left hand side, and here it is open from the right side, that is 1, right? So the fractional part of y, the range is from 0 to 1, right? Okay, so now these two concepts will be used to solve this integral, right? Now see, here the limits of integration vary from 0 to pi, right? So x, it lies between 0 and pi, right? And see, here we have x over pi. So what we will do, since the lower limit is 0 and the upper limit is pi, and x lies between 0 and pi, so let us divide throughout by pi, right? So what we will get, we'll get 0 over pi, and then here we have x over pi, and here we have pi over pi, right? So here we have 0, here we have x over pi, and this is 1, right? So from this inequality we see that x over pi, it lies between 0 and 1, right? Now let us come to the integral. So I can be written as 0 to pi, and the fractional part of x over pi can be written using this definition, right? So if we replace y by x over pi, then we have fractional part of x over pi as x over pi minus the greatest integer of x over pi, right? So here we'll write x over pi minus greatest integer of x over pi, right? So now we have this integral. So now we can write 0 to pi and x over pi dx minus 0 to pi, and here we have greatest integer of x over pi, right? Okay, now see, from this inequality we see that x over pi, it lies between 0 and 1, right? So here we have, say, 0, here we have 1. So x over pi, it lies between 0 and 1. So by definition of greatest integer function, the greatest integer of x over pi must be equal to 0, right? Because x over pi, it lies between 0 and 1, and by the definition of greatest integer function, the greatest integer of x over pi should be equal to 0. So this integral disappears here because greatest integer of x over pi is 0. So now we are left with only this integral, right? So we have here 0 to pi and 0 dx. So now we can write, we can take 1 over pi outside the integral, and we have 0 to pi, and here we have x dx, and the value of this integral is 0. So we have 1 over pi, this is x square over 2, and the limits are from 0 to pi. So this is 1 over pi, and we have pi square over 2, substituting the limits and taking the difference, right? So we have 1 over pi times pi square over 2, and here this pi get cancelled, so we are left with pi over 2, right? So the value of this integral is pi over 2. So viewers, this is how by making use of the definition of fractional part function and the concept of range of fractional part function, we can solve these type of integrals.